Hello, this is Mr. Henry, and welcome to lesson 4.14. This is the last lesson of the module, finally. So be prepared for tests, make sure your notebook's done, homework's done, all that kind of good stuff. Applications of systems of equations. Such a question says, how do I write and solve linear systems as word problems? So all the word problems we haven't done the past 3 or 4 lessons, here they are. Warm-up is a type 1. It says, what do you think the phrase verbal model means? So come up with your own little definition of verbal model. If you think you know what it means, put it down. If you have no clue, take an educated guess. Pause the video, do that. When you're ready, move on to the vocabulary. Hit play, move on together. There is no new vocab for this lesson. It's just going to be systems of equations and solutions and all that other stuff we've talked about before. So let's get started. So the first problem says, and the directions, write and solve the linear system. So we want to answer this question. It says the sum of two numbers is 361, and the difference between the two numbers is 173. What are the two numbers? Now you could potentially do a guess and check method and just keep trying numbers and seeing if it works out, just numbers that add up to 361, but the chance of you doing it quickly are not very good. So we're going to use a system of equations. To use a system of equations, there has to be two statements made. And this problem there is. The first statement here says the sum of the two numbers is 361. Right there, I can make an equation from that. So I'm going to let x equal the first number, and we're going to let y equal the second number. That way, whenever I put an x and a y down, I know exactly what they stand for. X is the first number, y is the second number. So it says right here, the sum of the two numbers is 361. So if I take the x, that's not an x plus y, if I add the numbers together, I get 361. So that is a true statement based off of the problem. Following it says the difference between the two numbers is 173. Okay, so if I subtract them, x minus y, I get 173. That's a second statement. It always kind of has to give you two, because if I just had one statement, it says that the sum of two numbers is 361. Well, that is going to give me an infinite number, or not an infinite, but yeah, maybe an infinite number of different answers, because I could take, well, 360 plus 1, 359 plus 2, 358 plus 3. And so by giving us two different statements, we now have a system of equations where we're going to get one correct answer. And the question asks us to find what are the two numbers. So I want to know x equals what and y equals what. What is the first and the second number? So I kind of jumped right to my equations here because I think this problem was especially simple because it was talking about numbers. But I mean, I could say first number plus second number. EC. Let's try that again. As second number equals 361. But I think this one was a little bit easier and didn't necessarily need that verbal model. But you could say first minus second equals 173. So these are the verbal models, and then that's the equations that it gets to. All right, so we're going to solve this system of equations. And the method I liked best in the last lesson was the elimination method. And when I look at these two equations, I can see I can eliminate. If I subtract, these are gone. If I add the two, the y's cancel out. So I'm actually going to add. I like adding better than subtracting when I'm eliminating, because if I add these two together, a positive y and a negative y is 0y. 1x plus 1x is 2x's, and 361 plus 173 is 534. Okay, divide both sides by 2, and x equals 267. I found the x value is 267. Okay, so now all we need to do is to plug that 267 into one of our other equations, one of these two, to find out what the y value is. Doesn't matter which one. I'm going to use the top one. So 267 plus y equals 361. The red might be a little hard to see in the tree, so I'll use black. So I'm going to minus 267 on both sides, and y equals, clear, 361 minus 267 is 94. The chances of you guessing the numbers 267 and 94 are pretty slim. And the chance of you getting it faster than I was able to do this method is also very slim. So those are two numbers that add up to 361, and when you subtract them, you get 173. Now this is more of an actual kind of wordy problem, so a verbal model will make more sense to do here. It says there are 356 grade 8 students at Euclid's elementary school. Okay, so there's a total of 356. 34 more than 4 times the number of girls is equal to half the boys. Oh my goodness, that's an ugly sentence. All right, let's see here. So 34 more than 4 times the number of girls. So 34 more than the girls times by 4, okay, is equal to half the boys. Okay, so that is our first statement right there. So that's my verbal model. It's ugly. I mean, that sentence itself is ugly. 34 more than 4 times the number of girls is equal to half the number of boys. But we can translate that into a math problem without much difficulty. 34 plus 4. Oh, I don't want to use G's and B's. I want to use X's and Y's. So let X equal, I don't know, girls, I guess. And let Y equal boys. Ladies first. So X is the number of girls, Y is the number of boys. Alright, so X is the number of girls, half of the boys. So how do you show half of the boys? Well, you take the boys and you divide by 2. Or you can put half the boys. Alright, so I have one equation. This equation right now, it would be impossible to find the value of the X and the Y just as it is because we have 2 variables. You only have one variable. So where's the other statement here? It's hiding in the first sentence. It just says there are 356 students at the middle school. Well, that means the girls plus the boys together has a total of 356. So if you take the X's and the Y's, the girls and the boys, and you add them together, there's 356 of them. So now I have my 2 equations. I'm going to rewrite them down here. So it's 34 plus 4 x equals 1/2 y, and x plus y equals 356. Now, you look at that and you think to yourself, well, we can solve this using graphing, using elimination, using substitution. My personal opinion here, I would solve using substitution. I see that this second equation, if I do one step, if I like subtract y or subtract x, that gets one of the variables by itself, then I can plug it in, solve, and I get my answer. I think the substitution method is probably the best method here. Now, what I'm going to do is I'm actually going to do this problem both ways. I'm going to use substitution and elimination just to show. So let me scooch this down, planning purposes. So I'm going to do the substitution method here and the elimination method over here. 34 plus 4x equals 1/2 y, and x plus y equals 356. All right. Substitution method first. So I'm going to take this bottom equation and I'm going to solve for x minus x minus x, giving me, oh, not x. I want to solve for y. I even put it under the y. I just said the wrong thing. I'm going to subtract y. So I get x equals negative y plus 356. Now, when you're doing this and you're taking your notes, you don't actually have to do both methods like I'm doing here. I should mention that. I'm just going to show both methods depending on how you like to do it. And since I now have x equals this stuff, I can plug that in to the other equation for x. So 34 plus 4 times negative y plus 356 equals 1/2 y. That is fairly ugly. And that is fairly ugly as well. Okay, so let's see here. Distribute. That gives me negative 4y plus 4 times 356. 4 times 356 is 1,424. I can combine my 34 and my 1,424 plus 34. That's combining like terms. 1,458. I'm going to break a rule here. Instead of getting rid of the variable on the right, I'm going to get rid of the variable on the left. It's not really breaking a rule. It's getting the variables together. And I know if I get this variable over here to the right, it's actually going to save me a step. So I'm going to add 4y to both sides. 1,458 equals 4.5 y. If you don't like 4.5, you can make it 4.5. That's the same thing. Which I probably, when I type this into the calculator, I'm going to use 4.5. Because we have to divide both sides by 4.5. Divide by 4.5, and y equals 1,458 divided by 4.5, back up, 0.5 is 324. So there's 324 y's. What was the y? Y is boys. So there are 324 boys. Does not look like there's many girls. Because in our equation, x plus y was equal to 356. I'm using this one here. And if the y is 324, to get to 356, we're going to subtract 324 from both sides. X equals, let's see, 356 minus 324 It's 32. There are only 32 girls in Euclid's middle school in 8th grade and 324 boys. So that is the substitution method. Pause the video if you want to keep it. I'm going to erase it because I need the space to do the elimination method. But our answer should still be the same. Alright, let's eliminate. So if you like the elimination method, here's how I would do it. First things first is we have to get our equations to look similar. So I'm going to get the x's and the y's on one side, like this bottom equation, and everything else on the other. So I'm going to take my top equation, and I have to do a little bit of work with it. So it's 34 plus 4x equals 1/2 y. I'm going to minus 34 to both sides. Actually, I lied. I was going to minus 34 from both sides and then subtract 1/2 y from both sides, but I can actually do this in less steps. Ready? Watch this. Minus 4x. That gives me 34 equals negative 4x plus 1/2 y. So I have my x's and y's on one side, everything else on the other. If I just flip-flop the two sides, negative 4x plus 1/2 y equals 34. Now it looks like the other one. Negative 4x plus 1/2 y equals 34. See what I mean when I said that this elimination method is not always the easiest way to do it? So now I have my two equations. This top one has changed. It's now here. And for me to eliminate these two, to eliminate the x's look like it would be easier, I need to multiply the top equation, or this equation, by 4. Where do I have space? Okay, I'm going to take both of these and slide them down here. Alright, so I have x plus y equals 356 and negative 4x plus 1/2 y equals 34. Okay, I'm going to take the top equation and multiply it by 4, which is going to give me 4x plus 4y equals 356 times by 4. Is that 14? It is. That's that 1424. There's negative 4x. I'm just bringing him over. Plus half of y equals 34. Now I can add these together, and that would cancel out my x terms because I have a positive 4 and a negative 4. So if these cancel, this gives me 4.5 y. This gives me plus 34. Is that 1458? And when I divide by 4.5, which is the 4.5, I still get y equals 324. And then I'd plug that back in, and I would still get the x value equals 32. So that's the elimination method. That's what I would have to do to eliminate these two. And I even took a few little shortcuts just because I know from experience some of the easier ways to do it. So honestly, I think the substitution method was the way to go there. Elimination method took some extra steps and some finagling and working around before we were able to eliminate. I mean, look, 1, 2, 3 steps even before we could eliminate and then solve. So, letter C. It says Nancy has $5 bills and $1 bills in her wallet. Altogether, she has 18 bills and a total of $62. How many of each bill does she have? If you could, please, what I'd like you to do is start by making your verbal models. Pause the video, make your verbal models, hit play, and then allow me to catch up. We'll check to see if our verbal models and our equations are correct, then finish solving your equations. Okay, so write your equations, then hit play, allow me to catch up, and then finish solving. All right, so our two statements. She has $5 bills and $1 bills. So I'm already going to start say, I'm going to let X equal the number of fives she has, and Y is equal to the number of ones she has. So my first true statement is altogether she has 18 bills. So the fives plus the ones, the number of them, equals 18. This is my verbal model. Now the number of fives we said is X. So X plus Y equals 18. Did you have that as your first equation? The second true statement is that a total of $62. So the value of the money is $62. And so the value of fives plus the value of ones equals $62. Verbal model. And so to find the value of fives, you take the number of fives you have and multiply it by 5, because each bill is worth $5. So if you have one of those, you'd have $5. If you have two of them, you'd have $10. The value of ones is 1 times the number of y's, which is the number of ones, equals 62. There is your second true statement and your second equation. So hopefully you had that. If not, go back and listen to my explanation again on how we got that. But if you had that, awesome. What I'd like you to do now is take the equations we have and solve them. Get one of the variables gone, so you only have one variable, solve your equations, and go from there. When you're ready to continue, hit play, and we'll go through it together. Okay, so I'm going to take all of this and just slide it off to the side, save some space. And the two equations I have are x plus y equals 18 and 5x plus y equals 62. Look at that. This problem is basically begging for us to solve using the elimination method, because we have here the same coefficient of y's. If I would subtract these two from each other, they cancel out and they're gone. So that's exactly what I'm going to do. I'm going to use this elimination method. And by subtracting, what we're going to do is we're just going to change the sign of all of these guys. So this is going to be like, you think, 1 minus 5 would be negative 4. So if I just do minus, and y minus y is 0, and 18 minus 62, see, that's 0, so he's gone. And 18 minus 62, clear, 18 minus 62 is 44 negative. Divide both sides by negative 4, x equals, boom, 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 11. So she has 11 of the x's, which is $5 bills. Okay, so she has 11 $5 bills. So using that bit of knowledge, we know, or we can figure out, how many $1 bills she has. Because of either of our equations, this top one, 11 plus the number of ones has to equal 18. She has 18 bills altogether. So if you subtract 11 from both sides, y equals 7. She has 7 $1 bills. And if you take that x equals 11 and plug it into the other equation, 5 times 11 is $55. It would take 7 $1 bills to equal 62. Either way, our solution is Nancy has 11 $5 bills and 7 $1 bills. If you were able to do that on your own, great job. Letter D. A friend bought 2 boxes of pencils and 8 notebooks for school, and it cost him $11. Okay, that right there, as I'm reading my problem, that is a statement that's eventually going to turn into an equation. 2 pencils, 8 notebooks, cost him $11. Okay, he went back to the store the same day to buy school supplies for his younger brother. Okay, he spent $11.25 on 3 boxes of pencils and 5 notebooks. That's another true statement. The question is asking, how much would 7 notebooks cost? So it's not asking us how much notebooks cost and how much pencils cost. The question wants to know, how much are 7 notebooks? So this is what we need to find. So let's start by let x equal the number of notebooks and y equal the number of pencils. Verbal model time. If you want to pause the video and try this on your own, you can. But I'm going to go through right now. So the first problem says he bought 2 boxes of pencils and 8 notebooks, and it cost him $11. So 2 pencils plus 8 notebooks was a total of $11. That is verbal model, which becomes an equation as 2y's plus 8x's equals 11. My other scenario down at the bottom of the page says $11.25 for 3 boxes of pencils. So 3 pencils and 5 notebooks cost $11.25. This is my verbal model. And pencils is the y, so 3y's plus 5x's is $11.25. Alright, so the 2 equations I came up with were here. I have 2y plus 8x equals 11, and 3y plus 5x equals 11.25. Now, the way that these problems are right now, I cannot just simply eliminate. These are not the same coefficient, these are not the same coefficient. So for me to use the elimination method, which I think looks best here, because they're already kind of set up for this. They have the x's and the y's on the same side of the problem. They look similar. So I think the elimination method is probably going to be the best here. But in order for us to do this, we have to do a little bit of mathematic finagling to make these equations eliminationable. Is that a word? So let's see here. I'm going to eliminate, doesn't really matter, the x's or the y's. I just have to figure out which one I want to use. So I'm going to eliminate the y's because the numbers are smaller. That's the only reason why I'm picking that. So I need to find a common multiple of 2 and 3. 6. If I multiply this top one by 3, and I multiply the bottom one times by 2, I'm going to have 6 y's on the top and the bottom. So let's do that. 3 times 2 is 6y. 3 times 8 is 24x's. 3 times 11 is 33. Okay, 2 times 3y is 6y. That was the whole point of multiplying by the 3 on the top and the 2 on the bottom, is so that those canceled. Plus 2 times 5 is 10x. And 2 times 11.25 is 22.5. Alright, so we now have 2 equations that we can use the elimination method because the coefficients are the same. So let's eliminate. Subtract them. And remember, when you subtract, you can just change the sign of the entire row, so minus, negative, negative. Makes my life easier. These cancel. Positive, negative, gone. 24 minus 10 is 14 x's. 33 minus 22 and a half, 10.5. Divide by 14, x equals 0.75. So it costs 75 or 0.75 x's notebooks. That doesn't seem to make sense. So let me check back up here. This is a mistake that you might run into as well, and I actually do know what the mistake is here. I said x is the number of notebooks, but it's not really the number of notebooks. I know how many notebooks he bought. He bought 8 notebooks here, and he bought 5 notebooks down there. So this is not the number of notebooks. This is actually going to be the price, or how much they cost. The price of the pencils. So 2 pencils times by the price of the pencils, and 8 notebooks times by the price of the notebooks would be $11. Okay, so I've now found the price of the notebooks, the x, is 0.75. I'll be honest, we could almost stop what we're doing right now and answer our question, but for sake of completeness, I'm going to find out what the value of y is, the pencils as well, but all we really needed is we needed the cost of the notebooks to figure out how much 7 notebooks cost. Now I'll do this first. We want to answer the question. So 7 notebooks is what we're trying to find. How much would 7 notebooks cost? Well, if one notebook costs 75 cents, one notebook is 0.75 cents, well then 7 notebooks would be that much. And I'm thinking that as a proportion. You could do it any way you want to do this. It's going to be the same math. We're going to take 0.75 times by 7 equals $5.25 for 7 notebooks. That is the answer to the problem. Now, I did say I wanted to find the value of y simply because it's practice solving the system of equations. So if the x value is 0.75, let's go ahead and find the y value. I'm going to plug this x into one of my equations. I'm going to plug it into, I guess it doesn't really matter. I'm going to plug it into the top equation. So 2y plus 8 times 0.75 equals 11. 2y plus 8 times 0.75, 6 minus 6 minus 6, 2y equals 5. Divide by 2, y equals 2.5. So it's $2.50 for a box of pencils. Okay? But the final answer, how much would it cost for 7 notebooks? That was the $5.25. Letter E. A farmer, I should say a farm, raises cows and chickens. The farmer has a total of 42 animals. One day he counts the legs of all his animals and realizes there are a total of 114 legs. How many cows does the farmer have? And how many chickens? Go ahead, pause the video. If you want a quick check to see if your verbal models and your equations are correct, you can hit play and let the video catch up and then continue the problem on your own. But either way, do the problem. When you're ready to continue, hit play, and we'll go through it together. All right, so we're talking about cows and chickens. So this question is asking how many cows and how many chickens. So the x will be the number of cows, and y will be the number of chickens. I'll make sure I didn't make the same mistake as the last problem. Assume it's the number of the thing, but it's actually like the cost or the number of legs or something. So how many cows does he have? How many chickens? Those are the things we don't know. In the last problem, we did not know the cost of the notebooks, and we did not know the cost of the pencils. That should have been my first clue. All right, so number of cows, number of chickens. So my verbal models are, the farmer has a total of 42 animals. So the cows plus the chickens equals 42. Verbal model, cows plus chickens is 42. One day he counts the legs of the animals and realizes there's a total of 114 legs. Well, you can say the legs of the cows plus the legs of the chickens equals 114. Verbal model. So the legs of the cows, well, each cow has 4 legs, so you take the number of cows and times by 4. Each chicken has 2 legs, so you take the number of chickens times by 2, and that would give you your 114. Okay, so we have now our verbal model. We have our equations that match the verbal model, that models the scenario in the word problem. So let's get to it. I am looking at my 2 equations here. I'm looking at this equation and that equation, and I'm thinking the elimination method is going to work. We're going to have to multiply the top equation by something. So I have x plus y equals 42 and 4x plus 2y equals 114. If I take my top equation and multiply by 2, and I leave the bottom one the same, I'm going to have the same coefficient of y, which means I can eliminate the y's and go from there. So that's what I'm going to do. So I'm going to take this top and multiply by 2, which gives me 2x plus 2y equals 84, and 4x plus 2y equals 114. I'm going to subtract the 2 equations, because 2 minus 2 is 4. So for me to subtract, I'm going to change the sign of the bottom. They now cancel. 2 minus 4 is negative 2x. 84 minus 114, I don't know off the top of my head, so I'm going to check it. Minus 84. I mean, like, that's the kind of problem you don't want to make a silly little mistake and think you know it off the top of your head, and you try it quickly and you're off by 10. Maybe you put 20, because that's really going to ruin the problem. Divide by negative 2, divide by negative 2, x equals negative 15. That does not make sense. I know why. Because this was supposed to be a negative 30 right here. Which means now when I divide, I don't get a negative 15, I get positive 15. I knew negative 15 didn't make sense because there's no way you can have negative 15 cows. That doesn't make any sense at all. So positive 15 cows. And how many chickens? So we're going to take that 15, plug it back in. I'm going to use the top equation because it's simpler. And so 15 cows plus the number of chickens equals 42, minus 15 on both sides. Y equals 42 minus 15. 42 minus 15. Backspace 15 is 27 chickens. So if the farmer has 15 cows and 24 chickens, I'm sorry, 27 chickens. I wrote it wrong. 27 chickens. He has a total of 42 animals. And all of their legs, if you count all their legs combined together, is 114 legs. There we go. Letter F, last problem. It says, the length of a rectangle is 4 times the width. The perimeter of the rectangle is 45 inches. What is the area of the rectangle? Go ahead and try this problem on your own. When you're ready to continue, hit play. We'll go through it together. Okay, so we talk about two things. What is the area? So the area of a rectangle is length times width. That's what's needed to answer the final question. Area is length times width. Do we know what the length of this is? No. Do we know what the width of this shape is? No. So that is our goal. We need to find the length and the width. My guess is I'm going to let x equal the length and y equal the width. Okay. So now, verbal model and equation time. The length of the rectangle is 4 times the width. Length is 4 times the width. So as a, well, this is our verbal model. As a system of equations, as an equation, we'd have x equals 4y. All right, now it says the perimeter of the rectangle is 45 inches. Perimeter is 45. Now, how do you find perimeter? Perimeter is 2 lengths plus 2 widths. Or when you think on a rectangle, if you have a rectangle, this side plus this side, so 2 of those plus 2 of those. You could also say length plus width, but it's the same thing. So this is kind of like my verbal model here. So I'm going to have 2 x's plus 2 y's equals 45. All right, so I now have my 2 equations right there. Looking at them, I'm thinking this is a substitution problem because this is already solved for x. So all I have to do is take 4y, plug them in here, solve the equation, and we'd be good to go. So that's what I'm going to do. So I'm going to take my 4y and plug it in for the x in this other equation. So 2 times 4y, that's the substitution from there, plus 2y equals 45. Notice, no more x's. That's the whole point. 8y plus 2y equals 45. 10y equals 45. Divide by 10, y equals 4.5. So we could say that the width of this rectangle is 4.5. Now all we have to do is take that 4.5, plug it into one of our equations to find the x. And I'm going to use this little equation. So change color here. X equals 4 times 4.5. And of course it's in the wrong place. 4 times 4.5 is 18. So we think that the length is 18 and the width is 4.5. So length equals 18, width equals 4.5. Let's see, did we answer the question? What is the area of the rectangle? No, we did not answer the question. We want to know what is the area. That's right, we have this guy here. So the area of a rectangle is length times width. In this case, 18 times by 4.5. So the area of this rectangle, 18 times by 4.5 is 81. And the label is inches squared. That is the answer to the question. We had to find the length and the width. We decided upon using x for length, y for width. We had our system of equations we came up with from our two statements. The substitution method seemed to be the easiest because this was a nice equation already solved for x. So we substituted and solved, found the y value was 4.5, plugged that y value into our little equation to find the x value is 18. That then told us that the length is 18, the width is 4.5, and that's the exact piece of information we needed in order to find the area. So we plugged in our length and our width, and the area was 81 inches squared. For our last summary of the module, we have 3 minutes on the clock, and it is a type 1. It says, just take 3 minutes to reflect on this module. Make a list of the new things you've learned throughout this module. So think about all the new stuff you've learned. I mean, we've talked about proportions and rates and constant rates and solving equations, systems of equations, slopes of a line, equations of a line, the different forms of an equation of a line. So reflect on all that stuff. Put down some new things you learned. Make a list. Go ahead, pause the video. This has been lesson 4.14. Thanks for watching.